In this video, we're going to look at slope-intercept form. So sometimes we have to write our equations and use equations that are in slope-intercept form. So we're going to look at a few examples. First example, find the slope of the line and the line is 5y equals x minus 3. So our first step is the best way that we can find out what the slope-intercept form is, put it in slope-intercept form. So slope-intercept form is y equals mx plus b. And so basically we want to get it into y equals format. In this case, we're not quite there. We have a 5 with the y, so we have to get rid of the 5. In order to get rid of the 5, it's multiplied, so the opposite would be divide. We're going to divide every term by that 5. 5 divided by 5 is 1, so 1y. Remember there's a 1 here, so if I have x over 5, I can rewrite that as 1/5 x. Make it easier. And then negative 3 divided by 5 doesn't go in evenly, so we're going to leave it as a fraction, negative 3/5. All right, now we have it in that format, so that's half the battle. Now, to tell what the slope is based on this format. So we said that putting it in this format was slope-intercept form. So that means it has a slope and an intercept, specifically a y-intercept. So when something is written in the y equals mx plus b format, the m stands for slope, and the b stands for the y-intercept. So now that we know that, it's the number in front of the x, the coefficient. So the coefficient in front of the x in this particular case is 1/5. So here, the slope is 1/5. Another example. Write the equation in slope-intercept form. So 2x minus 3y equals 6. We want it in that slope-intercept form, so again, y equals. This is not, so let's start. Well, we have a 2x there, so let's get rid of that first. It's positive, so in order to get rid of it, we're going to subtract it from both sides. That gives us 0 there, but we have the negative 3y hanging out. And then here, the 6 and the 2x don't combine, so we just tag them along. Negative 2x plus 6. And then we need to get rid of this negative 3. It's multiplied, so we're going to divide every term by a negative 3. So that over here we have 1y. We have a negative 2 divided by a negative 3, and although those don't go in together, we'll leave them as a fraction. A negative divided by negative is a positive, so we get positive 2/3 x. And then we have 6 divided by negative 3 gives us a negative 2. And so this would be our slope-intercept form. Next example. Graph using the slope-intercept form. So 2x minus y plus 4 equals 0. All right, so they want us to be able to graph this, but we want to use the slope-intercept form to do that. So we have to put this in slope-intercept form to start with. All right, so we're going to subtract the 2x from both sides. And so we have negative y plus 4 equals negative 2x. We have to subtract the 4 to both sides. We have negative y equals negative 2x minus 4. And now remember that negative y means there's a negative 1 in front of it. So we're going to divide everything by a negative 1. And so we get positive y, negative 2 divided by negative 1 is a positive 2, and negative 4 divided by negative 1 is a positive 4. So y equals 2x plus 4. Awesome, now we want to graph that. What does that mean? So let's give ourselves some room up here to see how we do that, how we go about graphing. All right, so let's leave that equation. That's what we want to graph. All right, so we know that we have y equals 2x plus 4. Remember, in this case, the m is the 2, that's our slope, and the y-intercept is at 4. So let's take a look at our graph. Draw that up real quick. Actually, I may not have made this big enough, so let me kind of make it a little bigger. There we go. Okay, so how we graph this is we start with the y-intercept. That's the first thing we plot. It's at 4, so we go to the 4 on the y. 1, 2, 3, 4. And then we use the slope. So we also have to remember that the definition of slope was rise or overrun, rise or fall. So in this case, our slope is 2. Remember, we can write any whole number as a fraction by putting it over 1. So that means we're going to rise 2 and run 1. So that means we're going to go up 2 spaces and over 1 from the y-intercept that we started with. So from here, we're going to go up 2 spaces and over 1. So that would be about right here. So notice 2 spaces, 1 space. And last but not least, we just play connect the dots. And there is the graph to that linear equation. All right, last example. What is the line of best fit? So line of best fit. Now what that means is if we want a line of best fit, that means we have collected some data and plotted those points and determine what line goes through most of those points or fits those points the best. So let's take a look at this example. They give you the graph first. So they've plotted all of these points. Kind of give us some landmarks here. And then on this one, they go up by 5s. Okay, so they just have some points on here already plotted. So let me get those plotted for us. Actually, I forgot to give us some landmarks here. So that's 5, 10, 15, 20. 40, 60, 75 at the top. Okay, so let's graph these. And then we have last but not least, we have Okay, so notice that these kind of follow a line. They're not directly in a line together per se, but they follow a general line. So if we were to kind of start this out and draw a line, I might draw a line that kind of goes like this. It might have gone higher, so let's undo that. Let's say maybe like this. And the trick is we want to, again, try to make as many on the line as possible. Or kind of have it in between where half are above, half are below. So we do have some of the points that were on the line that we want to point out. So starting here with this first point, this was at point 130. And then let's go with this point here. Oops. And that was at the point 760. So the trick is that you want to pick a couple points that are on the line, and that would be able to allow us to write an equation for that line of best fit. Okay, so let's see how we do that. Well, first, to find slope, slope is also defined in a formula where it's y2 minus y1 over x2 minus x1. And so we have these 2 points that we just found. We found the point 130 and the point 760. And we can label those as our x1, y1, and our x2, y2 point. Now we plug them in. So we're going to have 60 minus 30 over 7 minus 1. Well, 60 minus 30 is 30. 7 minus 1 is 6. 30 divided by 6 is 5. So now we know, as part of our equation, that m, or our slope, is 5 of this line. Now, how do we go about finding the other part, or our y-intercept? Well, good question. So let me erase some of this so that we can see what happens. So our slope-intercept form is y equals mx plus b. And in this case, we found m, we need to find b. However, notice that we have an x and a y. So if I plug one of our points in for x and y in here and our m, we can solve for b. So I'm going to use that first one there. So we have 30 equals 5 times 1 plus b. So we have 30 equals 5 plus b. Now we want to solve for b, so we're going to subtract 5 from both sides. And 30 minus 5 is 25. All right, so what is our final equation? Well, we plug in the m and we plug in the b. So y equals 5x plus 25. And that would be our line of best fit. That's it for this video. As you do your lesson, if you have any questions, please make sure to ask your teacher. Have a great day.